Good morning. This is Miss Swain from Montgomery Blair High School's Math Department, and I am going to do some practice problems for students in Miss Pope's class and Miss Swain's Algebra 1 class. And we are focusing on factoring polynomials using the first method, which is the greatest common factor method. Okay? So if you have your packet and you turn to page 37 and you count the sixth problem down, it should be 4x minus 32. Now 4x minus 32 is a polynomial, okay, because it has variable terms, a constant term with a plus or minus sign in the middle. This is just a polynomial, okay? And what we're going to do is we're going to factor this polynomial. And one way to factor a polynomial is, there's several methods that you can use. So the basic foundation method is the greatest common factor method. To do that, you compare like apples to apples, oranges to oranges, right? So you look at 4 and 32, and you ask yourself, what's the greatest common factor of 4 and 32? Basically, you want to know what's the biggest number that will divide evenly into 4 and 32. And you can use a multiplication chart to help you if you need one. And the biggest number that will divide evenly into 4 and 32 is the number 4. So you factor or pull that out. Now, notice this first term has an x, the second term does not. So they don't have any variables in common. So the greatest common factor of 4x and 32 is just 4. So you factor that out, okay? So we're going to factor out of 4. Notice I pull it out of the polynomial, okay? Like I pull it out. And then you put parentheses. And what would you multiply 4 by to get 4x? So you have to figure out, what's going to go here and what's going to go here. So 4 times what is 4x? 4 times x is 4x. So an x needs to go here. 4 times what is 32? 8. So this right here is the answer. So basically, let's break it down. What did we just do? 4x minus 32 can be factored. We factored it using the greatest common factor method. Ask yourself, what's the greatest common factor of 4x and 32? It's 4. This right here is the greatest common factor. This here is just the other, factor. So let's put it all together. Like, it's a few things I really want you to understand, right? The original problem, so let's kind of go back to the beginning. So the original problem was to factor 4x minus 32. And the method that we are going to use is called the greatest common factor method. So once again, what's the greatest common factor of 4x and 32? 4. Pull it out. 4 times what is 4x? X. 4 times what is 32? 8. This period, like the end of a sentence, this is the end. So this right here is the answer. But why is that the answer? There is a check that you can use to make sure that this right here is the correct answer. Like, did you factor it correctly? You only do this if you want to check it. Nobody's asking you to do this on page, when you all do page 38, you do not have to check it. But if you understand the check, it makes a lot of sense. So how do I know that this is the correct answer? Well, you can perform what's called a check. You can make sure that your work is correct, right? So let's just see what the check gives us. So if I take the factored form of the polynomial, which is 4 times the quantity of x minus 8, and you know this is basically using the distributive property. So you would multiply 4 times x and you get what? 4x. And you would multiply 4 times 8 and you would get what? 32. You got back to the original problem. That tells you that this is the correct factored form. All right? Okay, let's do another example. So I'm still on page 37. We're still on page 37. Let's try. So if you're on page 37, kind of just try to follow, and I'll give you a minute. Try to follow exactly which problems I'm on. I'm not going to do every single problem on page 37 because it gets a little bit repetitive. So let's just try another problem. Let's look at the second column, the problem at the top, right? So the second column, the problem at the top says 5x minus 5y plus 10z. So 5x minus 5y plus 10z. So let's remind ourselves this. What are we trying to do? We're trying to factor. We want to factor that. We're going to use the greatest common factor method. So look at look at the coefficients first, the numbers in front of the variables. 5, 5, and 10. What's the greatest common factor of 5, 5, and 10? What's the biggest number that will divide evenly into 5, 5, and 10? That's correct. My son is saying 5. That is correct. So 5, we pull that out. That's one of the factors. Now look at x, y, and z. Do they have anything in common? No. So of the variables, you cannot factor out a variable. So the only thing you factor out is just the number 5. What would you multiply 5 by to get 5x? X. 5 times x is 5x. What would you multiply 5 by to get 5y? Y. 5 times y. 5 times y is 5y. And what would you multiply 5 by to get 10z? 2 and then z. So you have to put a 2z here. And that's the end. This right here is the answer because this is the factored form of this polynomial. Okay? So one of the pages, class, period 4, Algebra 1B, period 4, one of the pages that I assigned for you to do is page 38. Okay? And yeah, you're doing page 38. And let me just say this. Just try it. This is one of those things where you have to be, math is one of those subjects where you just have to be super uber confident. Like overly confident. Okay? All I'm asking you to do is try. So use the greatest common factor method to factor the polynomials on page 37. I'm sorry, on page 38. Okay? Page 38. Now, another page that was assigned to you was page 45. So I'm going to do I'm going to just look at some of the problems on the page before that. So you're also going to do page 45. If you look at my MCPS, the assignments tab, so there are 3 assignments. One page is page 38. The other page is page 45. I have a producer. He's my son. Want to say hi real quick, Corey? No? Okay. So in order to do page 45, it's just more of the same. It's just factoring. Okay? Now let me just make one problem up. Let me just make something up real quick. Because sometimes you have these like exponents. Like you have variables that have exponents. Don't push the panic button. Come on, y'all. You know, we've been working with this stuff before. Let's not pretend that this is day 1 Algebra 1. Like we've talked about this stuff before school kind of shut down for COVID-19. So let's back up a bit. I'm going to do an example or two. This is not on any page. But say, for example, you had 10x cubed plus 4x squared. And what do we want to do? We want to factor this polynomial. How? Yes, I'll take water. So come say hi. This is my producer. This is my helper. This is my son. All right, I'm making a video. Bye. So, thank you. So, what if I wanted to factor this polynomial still using the greatest common factor method? The only difference is I have x cubed, x squared. I have these exponents. So let's still do the same thing. What's the greatest common factor of 10 and 4? What's the biggest number that will divide evenly into 10 and 4? 2. So you factor, once again, that's what you factor out, okay? You factor that out. 2. And then you have x cubed. You have 3 x's here and 2 x's here. You go to McDonald's. He has $3. He has $2. You're going to put in the same, common, but the highest amount, the highest same amount, if I'm even saying that correctly. But what's the greatest amount that you both could put in that's the same? He has $3, he has $2. How much? 4, but he only has $2. How can he put in $4? He has 3, he has 2. Can he give up $2? Yes. Can he give up $2? Does he have $2? So can he give up $2? So what's the greatest amount that they could both give equally? $2. Third grade student right there. I'm telling you, I am the best. I am the guru of Algebra 1. Shout out to Dr. Farah, Jefferson Junior High School, DC Public Schools. All right, back to the lesson. All right, so the greatest amount that they could both contribute could be x squared. So the greatest common factor this time is 2x squared. Still, same thing. And notice I always factor that out. Pull it like out of the problem. So now, 2 times what is 10? 5. X squared times what is x cubed? If you have 3 x's and you take out 2 of the x's, how many x's do you need left? If you have 3 and you take out 2, 1x. So 5x goes right there. 2 times what is 4? 2. I have 2 x's and I pulled those 2 x's out. Do I need any x's here? No, good. I could teach a third grader to factor. So you too, students, and Miss Swain's and Miss Pope's and any student around the country or at Blair, like wherever you are and you need help factoring, like all you have to do is rewind this video as many times as you want, but listen to just, it's common sense. You're just breaking something down into pieces, and those pieces are called factors. There you go, right. So I don't need an x here because this term only had 2 x's. I factored those 2 out. So when I put this 2x times what is 4x squared, just 2x squared times 2 will give you the 4x squared. So some problems will have exponents, some may not. Each problem is unique. You have to treat each problem as its own. If you can do math, you can do anything. You will be able to handle all the adversaries, all the situations, all the problems that arise in your life, unexpected with different variables, because math teaches you to think. And each problem is unique. You understand? So what you did the first problem may not be exactly the same method, I guess, but it will be the same method if you're working with the greatest common factor method. But the way you start problem 1 and the way you start problem 2 may be different depending on what each problem has in it. Okay? So,